Today we're going to be learning about isotopes. Isotopes is a group of atoms of the same elements that varies in mass and the number of neutrons. There are two notations for representing an isotope, and the first one is atomic name dash mass. So we just write the atomic name, then a dash, and then the mass that isotope has. The other way of notation is a superscript Z, subscript A with a regular X. Now our X is our atomic symbol, A is our atomic number, and Z is our atomic mass. Okay, so let's go and do some practice problems of doing isotope notations. So we're going to write the notation for the two isotopes of carbon, which has an atomic symbol of capital C, whose atomic number is 6. One isotope has 6 neutrons and the other isotopes have 8 neutrons. Now previously I said there's two different ways to notate isotopes. The first one is just the atomic name dash mass, and the other one was with the ZAX notation. So I'm going to show you how to do both. So first it's the atomic name dash mass. We have two isotopes. The isotope's name is carbon. So let's just go ahead and write carbon twice since we have two isotopes that we need to do two notations for. So we have carbon dash, and then we have another carbon. Now, then we need to do the mass for both of these isotopes. We are not given explicitly in the problem what the mass is, but we're given information we can use to find the mass. We know mass is protons plus neutrons. The problem doesn't give us protons, but the problem does give us the atomic number of 6. We know the atomic number equals protons. So carbon, protons are 6. It also gives us the neutrons of each isotope. Isotope 1 has 6 neutrons, and isotope 2 has 8 neutrons. So all we have to do is to add protons plus neutrons to get the mass. So if we want to get isotope 1, we have the proton 6 plus the neutron 6, so that mass is 12. So our first notation for our first isotope is carbon dash 12. Now isotope 2 still has a protons and 6, but we have neutrons of 8, so the mass is 14. So we have carbon 14. That is one way to notate. The other way of doing notations is with the AXZ operation. So, with that, X is our atomic symbol. We know the atomic symbol for carbon is C, so we're going to do 2 C's since we have 2 isotopes. And now the top number is going to be the atomic mass. And we just said that the atomic mass is going to be 12 for one of them and 14 for the other. And the bottom number is the atomic number, so we have 6 for both. So that's the two way of doing notations. Now the atomic mass in the periodic table is the average atomic mass of the element. And the average atomic mass is the average of all of their isotopes' masses. So taking all of the known masses of all the isotopes that element has, we would average them out, and that's how we get the mass we have on our periodic table. And we use an equation. We pretty much do atomic mass 1 times the abundance percent in decimal plus the atomic mass 2 times the abundance percent in decimals, and we continue that for how many isotope data we have. So with that idea, let's go ahead and do practice problems. We're going to calculate the average atomic mass of the following element with the following data. Problem number 1, we have 2 data for rubidium isotope. We have rubidium 85, it has a 72.2% abundance, and rubidium 87, which has a 27.8% abundance. So first thing we're going to do is we're going to start with our first isotope, and we're going to start with the mass of it. The mass of rubidium is 85. So we're going to start with 85. Now we have to multiply that by the abundance percent in decimals. So we cannot use this percentage value. We can do two things with it because we have to convert it to the decimal. We can either take this number and divide by 100, or we could just move the decimal twice to the left. And as a result, we get 0.722. And then we take that number, we multiply that by our mass. Now, since we have another data point, we're going to go ahead and put those two in parentheses, add, and move on to our isotope 2. Isotope 2 mass is 87. And again, we're going to multiply that by the percentage in decimals. So we either divide by 100, or we can move the decimal place twice to the left. We get 0.278, so we multiply that by the 87. That is all of our isotope data, so we're going to put that in parentheses, close it off, and we're going to plug it into our calculator. And when we do so, we get 85.556. The unit for average atomic mass is going to be AMU always. So whenever you're solving for average atomic mass, make sure that's your unit in your answer. So moving on to problem number 2. We have uranium, but now we have 3 data points for uranium. So we're going to first look at our first isotope information, which we have, our mass is 234, so we're going to start that off. Then we got to convert the percentage into decimal, either divide by 100, or we move our decimal place twice to the left. If you notice here, one of the loops has a number, but this one does not. So whenever that happens, we're going to put a 0 in its place. So it becomes 0.0001, which we use to multiply to our mass. We have another isotope, so we're going to close that off and add. Our second isotope data, mass, is 235. And we're going to multiply by that by our percentage in decimals. So we either divide by 100, remove our decimal twice to the left. Again, we got to add that 0, so we get 0.0071. We multiply that to the number, close it off, and we go again. Third isotope mass is 238. We got to convert our percentage into decimals, either divide by 100 or move our decimal place twice to the left. We get 0.9928, so we multiply that by 238. So that is all of our isotope information, so we're going to close that off, plug it into our calculator, and when we do so, we get 237.9783 AMU as our answer. We have 2 data points for chlorine. So our first mass for our first isotope is 35. Converting our percentage to 2 decimal places, move twice to the left or divide by 100, we get 0.7553. We have another isotope. That mass is 37. Converting that percentage to decimals, we can either move twice to the left or divide by 100. We get 0.2447. And we get 35.4894 AMU. So with that idea, go ahead and do example number 4 on your own. When you have your answer, press play. And here's your answer. And that's it, guys. Thanks.